James Enlelis.
And I'm Austin Hedeman, and we're here to introduce the online class Physics W89, Introduction to Mathematical Physics.
You took my line. That was supposed to be my line.
I like talking. You will see this in the videos.
Anyway, we will try and teach you about some central concepts of mathematical physics. Things like differential equations, linear algebra, tensors, which is this guy's
This is my favorite.
Yeah.
You'll hear me talk a lot about tensors. We've got a lot of really neat ways of working with it.
I think that the main purpose of this class is, in the way that it's distinct from a normal introductory mathematics class, is that we really want to stick to the physics concepts. So we're going to teach you about things like starting with waves on a string or a mass on a spring, or AC circuits, how molecules work, quantum mechanics of a few body systems. In fact, this is kind of all about waves on a spring. Are we just teaching them one thing?
Pretty much. I mean, you can build an entire curriculum out of oscillations and waves, and don't tell anyone, but that's what graduate physics is. It's all just oscillations.
Excellent. So I think we're going to introduce you to tell you a bit about what the topics are throughout this course. I'll hand it over to Austin for that.
Great. So yeah, so we're going to start with some mathematical preliminaries that are just really useful tools for all aspects of mathematical physics, and that's complex numbers and Taylor series. After that, we're going to introduce vectors. We're going to introduce vectors in a way that might seem a little weird at first, because we are going to be able to describe things like a wave on a string as a vector. And this is really going to open up a whole world of opportunities for us. Then we'll go on to matrices, which we can roughly describe as things we do to vectors, and specifically talk about square matrices. After that, we will introduce the eigenvalue problem, which is central to a lot of different fields of physics. We will learn about diagonalization, which takes a complicated problem, makes it an easy problem, basically one of our oscillators. Then, as we said before, I'm going to get overly excited about tensors. Then we'll go over to ordinary differential equations. We will learn some really neat series techniques like power series and the Fourier series and the Fourier transform. And we're going to wrap up the semester with an overview of partial differential equations and another really powerful technique, the Laplace transform and separation of variables. So that's the class. I do want to emphasize that I really love this class, and it's because it gives us an opportunity to sit back and say just how odd, how weird it is that we can even do physics in the first place.
And it's mathematics that allows us to do that. One thing that we should say is that we did design this course to be online from the ground up. So it differs a little bit from a regular class that you would have as a lecture series. We've designed it so that you can learn in this modular way. So you can always go back to material and revisit it if you feel like you need to catch up in some way. And not just for this class, but actually, hopefully the material will be useful throughout your undergraduate career in physics, and probably your graduate career too.
We certainly hope that that's how these videos will be used. And in terms of the other structure of the class, there's going to be weekly homework sets, there's going to be some discussion sections and discussion fora online, so that you actually get a chance to interact with your fellow students and your GSI and us, the instructors, even though this is an online and mostly asynchronous class.
I think that about wraps it up.
I think it is too. We're really glad you're thinking about taking this class. I hope we've convinced you. We both obviously really love the subject.
This is the best class that I've ever had to teach, and it's been my privilege to teach with Austin.
And my privilege to teach with James.
We hope you feel the same. See you later.